Our planet is speaking in a language of wind, water, and shifting temperatures. For centuries, we've tried to decipher its messages. But today, we have a new Rosetta Stone, data. This is the story of climate data science, an epic undertaking to listen to the Earth, understand its past, predict its future, and perhaps secure our own. We're re-embarking on a journey from the highest reaches of our atmosphere to the deepest trenches of the ocean, to see how humanity is building the most comprehensive health checkup in planetary history. Our first perspective comes from above. Orbiting hundreds of miles over our heads is a fleet of silent sentinels, satellites. These marvels of engineering are our global watchtowers. Instruments like NASA's Terra and Aqua satellites continuously scan the globe, measuring everything from the temperature of the sea surface to the concentration of greenhouse gases in the air we breathe. They use sophisticated sensors that can see beyond the visible spectrum, detecting changes in infrared and microwave radiation. This allows scientists to track the formation of hurricanes, monitor the health of vast rainforests, and measure the retreat of glacier with astonishing precision. Every pixel in these satellite images is a data point, a piece of a colossal puzzle. When stitched together, these images reveal long-term trends, showing us the subtle, yet relentless, warming of our atmosphere and the changing patterns of weather across continents. They are the unbiased eyes in the sky, providing a planetary-scale view that would be impossible to achieve from the ground. But a view from space is only part of the story. To truly understand what the satellite data means, we need ground truth. This is where a global network of terrestrial monitoring stations comes in. For over a century, thousands of weather stations, some in the most remote corners of the world, have been meticulously recording daily temperature, precipitation, wind speed, and atmospheric pressure. These long-term records are invaluable, providing the historical context needed to confirm the trends observed from space. And it's not just the weather we are tracking. Deep within forests, from the Amazon to the boreal woodlands of Siberia, scientists are conducting detailed field studies. They measure tree growth rings, which act as natural archives of past climate conditions. They analyze soil samples to understand how carbon is stored and released. Forest monitoring plots, where every single tree is tagged and measured periodically, give us a direct look at how these vital ecosystems are responding to a changing climate. Are they absorbing more carbon dioxide, or are they becoming more vulnerable to drought and fire? Each measurement taken on the ground, whether from a simple rain gauge or a complex gas analyzer, helps calibrate and validate the data streaming down from our satellites, creating a richer, more reliable picture of our world. While the land and air tell us much, over 70% of our planet is covered by the deep blue. The oceans are the Earth's great heat regulators, absorbing more than 90% of the excess heat trapped by greenhouse gases. To understand their role, we must venture into this vast, mysterious realm. A global armada of over 4,000 robotic floats, part of the Argo program, drifts with the ocean currents. These buoys dive to depths of 2,000 meters, measuring temperature and salinity before resurfacing to transmit their data to satellites. Their collective effort gives us a real-time, three-dimensional view of the ocean's thermal structure, revealing how heat is being distributed around the globe. Meanwhile, in the polar regions, scientists study ice. They drill deep into ancient ice sheets, extracting cores that contain trapped air bubbles from hundreds of thousands of years ago, a direct record of past atmospheric composition. They also track the movement and melting of icebergs, colossal pieces of ice that break off from glacier and ice shelves. Using GPS trackers and satellite imagery, they can follow an iceberg's journey, understanding how freshwater influx affects ocean circulation and salinity. From robotic floats to ancient ice, every piece of oceanic data is crucial for understanding the engine room of our planet's climate system. Collecting this torrent of information from air, land, and sea is a monumental achievement. But the data itself is just the beginning. The next challenge is to make sense of it all. This is where the world's most powerful supercomputers enter the scene. Climate scientists and data engineers feed this diverse data into complex global climate models. These are not crystal balls, but sophisticated simulations of the Earth's climate system, based on the fundamental laws of physics, chemistry, and biology. They divide the planet into a three-dimensional grid, and for each cell in that grid, the model calculates the interactions between the atmosphere, oceans, land, and ice. By running these models with historical data, scientists can test their accuracy. If a model can successfully replicate the climate of the past, we can have more confidence in its projections for the future. These projections are then transformed into powerful visualizations, maps that show future temperature increases, graphs that chart rising sea levels, and animations that depict changing weather patterns. These visualizations are not just for scientists. They are essential tools for communicating the realities of climate change to policymakers and the public, transforming abstract numbers into a tangible vision of the world to come. So, what does the future hold for climate data science? It's a future of even more data and even greater insight. New generations of satellites with higher resolution sensors are being launched. The network of ground and ocean sensors is expanding. And with the rise of artificial intelligence and machine learning, we are developing new, more powerful ways to analyze this data, uncovering patterns and connections that were previously hidden. Climate data science is no longer just an academic pursuit. It is at the forefront of our global response to climate change. Its findings inform international policy, guide the development of renewable energy, and help communities prepare for impacts like floods and droughts. The work of these scientists, engineers, and data analysts is a testament to human ingenuity and our collective will to understand and protect our home. The Earth will continue to speak, and thanks to the ever-evolving field of climate data science, we are learning to listen more closely than ever before. Thank you for watching. If you found this journey insightful, don't forget to like, subscribe, and share.